Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 2067, number of equal count substrings. So pretty straightforward. You want to find all the substrings where every single unique letter has this frequency, right? And then count the number of substrings. So let's do exactly that. So for I in range length S, let's get every substring. So including the current character, so getting all the substrings until the end. So let's go ahead and make a counter because we're going to get the frequency of the current substring, and then we're going to say, so if any frequency is already over the counter, then it's not possible, or over this count, right? So if, let's call this big, we're going to keep track of the maximum frequency we find, right? So big is the max of big and C of S of J, so any frequency that is changing or occurring. So if big happens to be bigger than count, then we break. We don't even have to continue this loop anymore, right? Otherwise, if big is equal to count, cool. So at least the most frequently occurring character is equal to count, and the minimum, the least frequent occurring character is also equal to count, then we can say that's another substring that counts, right? Okay, cool. And at the end, we can just return this because we got all the substrings that satisfy this criteria, breaking early to sort of save a little time there. So let's run this. Okay, so submit it. So this is still n squared and it's going to time out. Cool. So basically, also, if you notice, if the whole thing is just going to be only one character, then what we have, for example, if we have this and count is equal to 4, then we only have 5 substrings, right? 1, 2, 3, 4, and 5, right? Because it's going to be how many windows of size count we can make in that substring, right? Because we're going to divide it substring times, because if we want exactly count times and there's only one character in the whole string, then that's just going to be, that's the amount of substrings that satisfy exactly this criteria in terms of the most frequent and the least frequent character, right? Okay, so let's go ahead and do exactly that. So if length of set of S is equal to 1, the whole substring is only one character, then let's go ahead and make chunks of size count inside of S and increment answer, and then return answer at the end. Okay, cool. So last but not least, we can also do some optimization here because as we're moving along, right, as we're finding the substrings, if we get to a point where the maximum frequency of any character that we've seen, so we're going to make a counter of the entire S. If the maximum frequency at this point is going to be less than count, then we don't even have to keep searching. We can just break right away because we know it's impossible to satisfy count, right? So tot of S of I minus equal to 1. If tot of S of I is equal to 0, then delete it from our dictionary. So after we visited all the substrings starting from that character, then we're going to delete that character and move forward, and that's going to help us save a little time as well. So if the max of totes.values is less than count, again, we can break just to save a little time there, right? So let's run this. Okay, submit it. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.